So the next thing we're going to do here is going to graph absolute value. I forgot to change that. We're going to graph quadratic functions. So the first thing we need to know is where to begin. And the vertex tells me that. Where do I begin? Well, the opposite of what I see. The h has to be opposite of what I see. I see a positive 2 or a plus 2, so that's going to be opposite, negative 2. For k, what I see is what I get. WYSIWYG is 3. So we can plot that over here, negative 2, negative 3. Now let's continue. Remember that your axis of symmetry is always whatever your x value is. So here, if I were to sketch that, it's just a little dashed line here. You don't ever really need to sketch it, but for our purposes today, we will. Next, which direction does it open? Well, let's see here. What number is a? Well, a equals positive 1. So because a is 1, and you don't need to always have a is 1 as a mark, that's just for us to remind ourselves, this opens up. Or I could circle the up there. And since a is 1, my pattern is 1, 3, 5, etc. And let's always recollect that it's always over 1. Even if it were a fraction to begin with, it's over 1. So let's attack, kill, destroy. From this, I need to go up 1, and then right 1, and then I reflect it across the axis. Now we're going to go axis of symmetry. Then we're going to go up 3. 1, 2, 3, and right 1. So that puts me here, and we reflect that one over there. And I'll finish this one up by going up 5, 1, 2, 3, 4, 5, and right 1 to be there. And I reflect that across the axis to be there. And we gently make our curve work without getting in the habit of straightening our lines, because it's a curve, not a line. And there we go. If you were to describe this, if you were to describe it, let's use descriptive words. All we do is shift the parent function down 3 and left 2. And that's it. There's no stretching and there's no flipping. So if you were asked to describe, all we're doing is taking the exact same function, this guy right here, the graph, and we're just moving it to a new place. And we're not stretching it, no rubber banding, no flipping, or anything like that. Describe to your neighbor down here what's happening. So in other words, what's the vertex, axis of symmetry, open up or down, and pattern? Talk to your neighbor, go. And then we can check our work with the try it. So let's now look at example C here. The things that we need are the opposite of what I see here. I see a negative 3, so that's going to be a positive 3 there. Exactly what I see here, so that one's going to be a negative 4. So there's my vertex, 3, negative 4. 3, negative 4 is right there. Next, the axis of symmetry is the x value, so x is 3, and I can graph that looking like this. It's just a vertical line passing through the x-axis at 3. Next, up or down? Well, again, because a is positive there, this one opens up. And my pattern is going to be double the pattern. Because of this 2, we're going to double the pattern. So it's 2, 6, 10, etc. Now the 10 probably is going to take me off grid, so my guess is we won't even get to that far. We'll just get the 2 points beyond. All right, so I count up 2, 1, 2, and right 1. So there we go, here and reflect. Now I'm going to repeat, but using 6. 1, 2, 3, 4, 5, 6, and right 1 puts me there, which will be here and reflected across. Notice that it does look more narrow than the red parent function. Again, I like to start sometimes with the vertex when I am struggling with what to do, and then work it so it gently curves that way. All right, done. Took me more time to get that little curve curved than it did to actually do it all, besides the drawing part. Your turn. Unpack h of x. Go. And we can check our answer here. Now let's look at D. A couple things that we can see here. Opposite of what I see right here. So my vertex is -1 and -5 there. Another way to describe that is the shift. It takes the entire shape, the parabola, and I move it left 1 and down 3. While we're here, we can go ahead and graph that. Left 1 and down, down 3, down 5, I meant. So here's my new vertex of this function, y. Axis of symmetry is always the x value, and it's a vertical line that passes through that. Next, we know that because of the positive in the front, we know that this opens up. And the 1/2 is important because it tells me the pattern. So it's going to be 1/2 times my parent pattern, 1, 3, 5, etc. And we've already done that before. So we get 1/2, we get 3/2, 5/2, etc. Now, as we pointed out, it's always a big over 1 because we always move left or right, 1. So some of us might need to think about, instead of halves, you can think about it as decimal too, 0.5. This one's 1.5. This is 2.5. If that helps, we can do that. So now we're going to go up, because it's moving the upward direction. We're only going half. According to this, we go up 1/2 and right 1. Up 1/2 and right 1. So we're going to be in that location there. So we're right here. And I'm going to reflect it across the axis of symmetry, right there. Now I'm going to repeat the process, but now I'm going to go up 1.5 and then right 1. So here's 1/2, another 1/2, and 1.5 puts me here, so I go right 1 there. So now I'm in a nice corner there, and I reflect across. The next one is 2.5 over 1. So up 1, up 2, halfway is between, and then I go right 1 to be there. Now it turns out we actually have enough room. We could do the next in the pattern, which is 7/2. So while we're there, I might as well do 3.5 over and then over 1. So let's do that. So there's 1, there's 2, there's 3, and there's 1/2, and we go right 1 and reflect across. So notice that my green curve here, my parabola, is a little bit more wide than the red parent graph there. All right, so if asked to describe, let's put it in words. We're going to talk about the shifting and the opening and the fact that it gets a little bit more wide. So, and usually the description is compared to parent function. We compare it to the original. So in this case, we're going to compare it to the red curve there. So what are some things? Number 1, it shifts or translates down 5 and left 1. Next, we can say it opens wider and up. And there we go. That's a quick description. All right. The next skill that we're going to look at is how do we get the function from the graph? So we're working backwards now, which is actually nice because there's a little bit less work. All we're doing is identifying things. We're going to identify and substitute. That's it. We identify what all my things are, we substitute, and as usual, we simplify where we can. So we identify the whether it opens up or down. We identify what the h and the k are. We identify what the pattern is, and then we just simplify. Because sometimes we'll get double negatives, etc. So first off here, I look at the vertex. And here's my vertex right there. So we see that's at positive 1 and negative 3. So there's my vertex. So I'm going to put those in their correct places. Remember that the h will go right there. So, and the k is going to go right here. So we have to watch out, especially for your double negatives, etc. So, when I start to substitute things in, so our vertex here is 1, negative 3. And where do things go? So f of x is equal to, I'm leaving some space because I don't know what the a is going to be yet. So we say x minus, and now I just put the 1 in there. Don't forget your square. Don't forget that this is a minus 3 now over there. All right. Clearly we see this thing opens up. So that means a has to be positive. So a is positive. And next, all we need to do is look for the first term of the pattern. So before, our base pattern was 1, 3, 5, etc. But whatever the first pattern is, the first term, that always ends up being a. So watch the magic on this. Notice to get to my next nice point, 1 to the right, I have to go up to this point right there. So what is my, essentially we're thinking about slope to the, to how do we get over 1? We're not going to the next nice point here. This coincidentally is a nice point. We're always going right 1, and then how far up do I go? And that right there, how far up I go when I go right 1. So let's just clarify the first term of the pattern. For this one, we always go right 1, a complete right 1. And you can, technically you can go to left 1 too, it doesn't matter. But the important part is that we go to a whole unit right. And then we just count the slope there. So when I do that, I get this. Right 1, so the up 2, this. The up, that's my a. And a is positive from below. So all I do is plug that in. A goes there. And I just double check, is there any double negatives to pay attention to or anything to simplify, and nothing to simplify, and I'm done. So I identified my 4 things. What were the 4 things? Number 1, I found h. Number 2, I found k. Together, that's the vertex. Number 3, I just determined whether things went up or down. And number 4, I identified the first term of the pattern. Take a moment here to check your answers on the rest of them. The last thing we're going to look at is sort of an impractical practical situation, because clearly you're not going to be looking and thinking about parabolic functions when a goal is being kicked, and you probably won't even know what the function is when you're doing it, okay? If you are doing computer graphics, though, the computer graphics actually follows models like that. So this is applicable for those who are designing video games, but obviously in real life it's a little bit more of a stretch to consider that we're going to be using the function here. But we'll at least work through it. So Chris and Maria are playing soccer. Maria takes a shot of goal. Maybe I meant to. Yeah, no, that's weird. Takes a shot at the goal, something like that, or for goal. All right, so Chris is 3 feet in front. So just to make note of, clearly we see that the goal is at the 25. So if he's in front, let's put what looks like his hands are at 22. His hands are at 22. Okay. And he can reach the top of the 8-foot goal when standing directly beneath it. So just stretching, not jumping. All right, and it does look like he's on his tippy toes, which seems to be legitimate here. Can he block the shot from his position without moving or jumping? So let's see what happens here. Of course, what we're trying to consider is the projectile. The projectile, and you don't need to draw this, is going this way, right? And it looks like it's, I mean, if I were to guess, it looks like it's going like this, but I can't quite, because my estimation, I don't know if it's going to hit the top of that, if it's going to pass it, just because my estimation on the graph here might not be so good. So we can do some calculations. So let's see here. We know that this point right here where he is reaching, this point right there, and let's go ahead and label that point, that is at 22 feet, 22 feet and 8 feet high, okay? And we're wondering, it looks like, I'm guessing that it's going to be, or I'm estimating that it's not. He can't grab the ball. But of course, we don't know if it's making a goal either. That's the next part here, if Maria did make the goal. So let's see how to do this. Well, we know that our super secret formula looks something like this, where we have a times x minus h, and this is called vertex form, of course. And we know what the vertex is. We know what the vertex is. We have 16 here and 11 here, so we can plug those in. Now, I'm going to teach you a little bit of a trick here. Notice I'm leaving some blanks, so I suggest leaving the same blanks as I did. 16 goes there for h, and the k is 11 feet up. So that's the height the ball gets to, and it looks like it's the maximum. The highest the ball goes is at 11 feet. Now, I taught you to go from the vertex and go to the next point 1 over. We can't do that because we don't have the accuracy of the graph here. Watch if I try to do that. I'm here, and 1 over is right here. That is 16. 1 over is to 15. But I have no clue what the value is of this point right there. I don't know how high it is. I could take a guess, 15 and a half, something like that. But I don't have enough information. So since I can't use the next point over, that's 1 unit over, I'm going to use another point that I know. Doesn't matter how far away. So all you're going to do is take those two values and plug them in for x and y. So I'm going to put the 1.2 here, the y, and I'm going to put the 2 here in for x. So with that in mind, we have exactly one variable left. So when I simplify everything and solve for a, I get a. So step by step. 1.2 remains the same. A remains the same. Inside simplifies to negative 14. The square stays the same. The plus 11 stays the same. Actually, while we're here, well, I'll go ahead and subtract. I'm going to do two things. I'm going to subtract 11 from both sides. So we get negative 9.8 equals A times 196. Where'd that come from? Negative 14 squared is 196. Now notice all I need to do here is divide by 196. Divide by 196. Pull out our calculator for that. So here I get A is negative 0.05. All right, there was probably no way I could have accidentally guessed what that 15 value was to have gotten that. So I now have the function here. Here's my function. Negative 0.05 times x minus 16, that's part of my vertex, plus the 11. So step number 1 was to calculate A. Now, step number 2, we have the function. And what can we do with that function? Well, I can see what the height of the ball will be at 22. So, what's the height of the ball at 22? Or the altitude of the ball at 22 feet? Well, I'll plug things in. Y equals negative 0.05, 22 minus 16, quantity squared, plus 11. I'll do a little bit of simplification, but really all of this can go into your calculator. Here we get a 6 squared plus 11, and I'm going to plug that into my calculator to see what we get. And we get 9.2 feet. So now we can answer the question. When standing, can he block the shot from his position? He reaches 8 feet. The ball is going to be at 9.2 feet. So Chris cannot reach the ball without moving.